All right, everyone, it's the review you've all been waiting for. Sound effects. Wah, 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 wah. The exam review. Now, I might not go into all the details that you are hoping for, because I am assuming that you have learned this stuff before. You have learned all this stuff before. If you want more minute details, you might want to check out the old reviews that we've posted throughout the semester. Not saying I won't go through these problems or anything. I'm going to go through these problems and how to do them, but you might be wondering, where is that information coming from? We've done this stuff before, so I'm not going from step one. I'm going from assuming this is a group that has done some of them. I can't speak, but let's just get to it. Like, for instance, I'm not going to explain that arithmetic in great detail, what arithmetic is. I know arithmetic means we are adding the same or subtracting the same thing every time, like we are here. I go to the positive numbers, I say, hey, I'm going up 5 every time. Is that what's happening every time? Absolutely. So I'm arithmetic. What I just said is describing a way, adding 5 every time. A definition for the nth term. For some reason, this throws people off. The nth term, oh my gosh. This is really just asking you for your most basic y equals mx plus b from Algebra 1, and even before that. Okay, I just want to know what's happening every time. So instead of x, you can use n if you want to. Okay, so I'm doing 5n every single time. But if I did 5 times 3, I wouldn't get 3. I would get 15. Right? Well, how did I get to 3? Well, I had to take 12 away. Well, does that work every time? 5 times 4 equals 20. Take 12 away. We got 8. 5 times 5 equals 25 minus 12. Oh, hey, if it works 3 times, that is the rule. Okay, so 5n minus 12. You can also think back to your Algebra 1 days, your y-intercept, right? Your y-intercept, that b, that number at the end there, it's always when x equals 0. Well, if I went backwards, I start on term number 1 here, but if I went backwards to term number 0 and I took 5 away, I would get that number that was there. And there's my y-intercept. So there's a couple different ways that you can find your y-intercept there. So there is the nth term, 5n minus 12. There's different ways to use the formulas on your sheets, but I think using your logic there is going to help. I can plug 8 in to this equation. 5 times 8 is 40 minus 12. But especially if you're not that confident that maybe you wrote the right definition, maybe you just continue your table. 6, 7, 8, 13, 18, 23, 28. Whichever way you want to prove that you got to 28 by the time you got to the 8th term. It's a sequence, arithmetic, or geometric. Well, I see this line isn't straight, so I'm going to guess it's geometric. And if I actually see what's happening here, I go from 2. That's the y value I'm writing here, by the way. So we got 1, 2, 2, 4, 3, 8, 4, 16. I actually noticed that I'm doubling. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I would assume the next number is going to be, well, I don't have to assume. It's right there, 32. If I didn't know that, you could go backwards and say, what's 32? Maybe let's start earlier. 8 divided by 4. That gives me my rate, 2. Okay, so describe a way to produce each new term from the previous term. Multiply by 2. Nth term. I just figured out the rate. Okay, so I would go 2 is my rate. That's a big part of going to the nth term. I see that this type of growth is exponential. So I'm actually thinking about the unit 4 stuff we ended the semester on. I'm thinking, okay, 2 to the power of n. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. So I realize it's not always going to be this easy, though, right? So with these exponentials, remember what you can do is say it goes starting point, rate to the power of n. So I would actually have to go backwards to find that starting point here. Again, going backwards, if we're multiplying going forward, divide on the way back. 2 divided by 2 is 1. My y-intercept here is 1. Now you see why we don't write the 1. Multiplying by 1, we don't really need that, right? So 2 to the power of n works. There's also, I believe you could have written this as 2 times 2 to the power of n minus 1. If you're using your formula sheet, that might be what you get. I shouldn't say I would rather. What I would do is look to my starting point, put it at the beginning, and use my rate to the power of n. Be 7. So again, you can continue multiplying on, maybe just because of my space issues here. I could write 32, then 64, then 128, and I've produced my 5th, 6th, and 7th term. Right, and that's showing what I did. I could also have said, okay, 2 to the power of 7 equals 1. All right, and this is every time I do a video, I get nervous and make sure I'm recording. I think I am. I better be. I don't even come near that button when I'm doing this. Don't want to accidentally not be recording. Got me thinking about it. Let me see. Okay, it says pause stop, which means I am recording. Cool. Okay, graph the following by n behavior, zeros, multiplicity, y-intercept. Okay, so figure out your lead coefficient, degree, and that's going to give us our n behavior. So lead coefficient here, I've got nothing but ones in front of these x's, so my lead coefficient is 1. My degree, this exponent here is 1. 2 and 1 make 3. Okay, the lead coefficient is a positive number because this is positive. That means as x goes up, y goes up. So I might even put my arrow on there before I even begin drawing. X is going up, left to right, y is going up. The degree of 3, that is odd. Odd. Look at this dance. Look how odd I look. I'm going in opposite directions. This arrow is going up, which means the arrow going the other way is going to go down. In other words, as x goes down, y goes. Okay, so I've got my end behavior. Let's figure out our zeros. So you guys probably don't see this, but I got to move my face to the other side of the video because I want all the room that this offers me. Actually, I don't even need it in this problem. Okay, so my zeros, all that for nothing. My zeros here, if I've solved these for 0, my zeros would be positive 4. The multiplicity of that 0, because it's being taken to the first power, is 1. And that is an odd number, right? This is the number I worry about, whether it's odd or even. Odd means I cross. Even means I bounce. Okay. The multiplicity, not the 0 itself. The multiplicity of the 0 determines that. All right, so the 0 of 4, multiplicity of 1. So we are going to cross. 0 of -1, the opposite of that positive 1 there. The degree is 2 there, so the multiplicity is 2. We are going to bounce. Okay, so if you want to draw these as you go along, 1, 2, 3, 4, -1 is my other 0. Personally, I like to find the y-intercept before I draw the rest, before I draw the whole thing. My y-intercept, I take 1, square it, and multiply it by -4. 1 squared is 1 times -4. We have a y-intercept of 0, -4. And that should make sense. So when I finish drawing this, go up when I get to 4, I'm going to cross like I said I would. Need to pause recording. Make sure I didn't make a mistake here. Okay, we're back. So I was getting nervous there because I hadn't, let me mark my y-intercept, -1, 2, 3, 4. Because my 0 of -1, for some reason in my head, I was wanting to cross there, but -1 is an even multiplicity. We need to bounce. That takes me down to the y-intercept. And then I go back up and I cross at +4. So got a little gun shy there, but just double check, figure it out. Double check where my zeros are supposed to be. Bada boom. Okay, same issue here, or I should say same type of problem. We're going to find n behavior, zeros, multiplicity, and y-intercept. So let's start with lead coefficient, degree. That'll help me with n behavior. Lead coefficient 3. Everything else is a 1, so 3, and that is a positive, which means that as x goes up, y goes up. My degree, I've got 3, 1. Don't forget about this 1 here. 3 plus 1 plus 1. The degree is 5, which is odd. So as x goes down, y goes down. Okay, so on the opposite end, going down. Okay, let's get our zeros. Their multiplicity, whether they'll cross or bounce. The 0 that most people forget to do, 3x equals 0. When you solve that, you would have an x that equals 0. So we have a 0 of 0, which has a multiplicity of 1, which means we'll cross. That means we're crossing at the origin. We've just taken care of our y-intercept. We are at the origin, we have our y-intercept. The other 0 will be 4, multiplicity of 3. And again, we will cross. And then your -5, multiplicity of 1, which means we cross. This 0 right here means my y-intercept, if you multiplied 5 times 4, anything multiplied by 0 is going to be 0. So we're at 0, 0. All right, so mark 0, 0. We're at the origin. We're at +4, 1, 2, 3, 4, and -1, 2, 3, 4, 5. We are crossing at everything here. Crossing. That's not always true, but these all have odd multiplicity. So we crossed every time. Okay. This is one of the problems where you're going to do work and you're going to point out other people's mistakes, right? When you're pointing out someone's mistakes, make sure you know how to do it on your own. So all of the zeros, okay, we've got a 0 here of -1. multiplicity is odd. We've got a 0 of +1. Multiplicity is odd. Well, how do I know that? Because it's crossing or bouncing. Okay, we've crossed. Again, we've crossed at +1, right? And -1. At +2, we are bouncing, therefore we are even. The sign of the leading coefficient. Well, I see that these are going down. Therefore, the sign of the leading coefficient needs to be negative. Degree of the polynomial is even or odd. Both of these arrows are going straight down. Therefore, it is even. Y-intercept, 0, 8. Okay, so based on these things right here, okay, I have a negative lead coefficient. I'm going to leave a little gap. I have a 0 of -1, which means I had a factor of +1. I have a 0 of +1, which means I also have a factor of -1. And a 0 of 2, which means I would have x minus 2. It's even. I'm going to go with the most basic even number here and go with 2 to the second power. Now, if I did all this, -2 squared gives me 4. Okay. 4 times 1 times -1, my other two zeros or factors, whichever you want to think of it as, would give me -4. But I'm not at -4. I'm at +8. -4 times negative, well, that takes it from being negative to positive, but what's going to take it from 4 to 8? Well, 4 times 2 is 8. So I'll put -2 over the front. Okay, Sam declaims that x minus 1 is a 0 with a multiplicity that is even. Okay, I agree that this is a 0, but we crossed. X equals -1 is a 0. But multiplicity is not even, is odd. Because we cross. Okay. So that's the first statement. Maybe I'll change colors each statement. The leading coefficient is negative. I agree. I agree. Lead coefficient is negative. Negative. Because it's a couple different ways we could say it, but you can say, hey, as x goes up, y goes down. Right, this arrow right here, that proves that we're negative. The degree is odd, something I disagree with again. Degree is odd. Actually, I disagree because degree is even because both directions point down. So between my words and my handwriting, hopefully you can understand one of them. So these are all the claims that were made. We agree with the middle one, but the other two we disagree. We got to give a reason why we disagree with it as well. All right. Onward. Okay, so in a problem like this, we got to think what is being given to us? Height above sea level. Okay, that's being given to us at 200. Okay, and that was the h. So we need to figure out the distance if h is 200. Okay. That ended up being 600 divided by 2. 300 square root of 300 ended up being 17.32 miles. We're going to need, why did I write miles over there? I don't know. We're going to need that information later. Rachel can see 6 miles in the horizon. That is giving a distance this time. This is D. So now we have 6 equals root 3h over 2. And if you're in my class, you know I'm a little mad I didn't give myself more vertical distance with this. How do I get rid of this square root? The opposite is to square it. So I don't like solving from left to right here, but now I have 36 equals, I've gotten rid of that root. Now I have 3h over 2. I'm trying to get h by itself. Right now, the 3 and the 2 are keeping it from being alone. I'm going to multiply both sides by 2. That takes care of that 2. So now I have 72 equals 3h. I don't want to know 3h. I want to know h. So divide both sides by 3. 72 divided by 3. We get h equals 24. Domain and range in this, remember, domain is x, range is y. In this scenario, you're not going to have a height above sea level that's negative, right? So we need to say that, hey, x is greater than equal to 0, right? Or just state positive numbers. Y, again, your distance, okay, your distance for the range is not going to be in the negative in this case. So again, y is greater than equal to 0. Again, we're thinking positive numbers. Okay. Now, if you double your height above sea level, does that mean the distance that you can see to the horizon is also double? There's many ways to do this. It says table, graph, equation. If I'm going to show a table, which I'm going to need an equation to use. If you use a graph, you got to be specific with the graph and actually use points, okay? Now, the good thing is we've already done some work. We know that when our height above sea level, our h, is 200, we know that our distance I need a new table. I need more space for this table, I should say. Well, we'll be all right. 17.3. Okay. Now it says if the height above sea level is doubled. So let's double that 200. Let's make it a 400. And just do everything we just did in this first equation. The square root of 3 times 400 over 2, right? And you get 1200 over 2, square root of it, equals square root of 600. And the square root of 600, I'm just double checking. I did it earlier. We end up with 24.49. Now, we doubled the height, 24.49. Sorry about that right there. Sorry about not being able to read it. Okay. We doubled the height. It did not double our distance. Okay. Because 17.3 times 2 is 34, of course. Okay. So when we doubled the height, when height doubled, distance, I mean, we could be specific, went up, what it went up about 7.1. it would have gone up, would have been up, would have increased 17.3 if we had. Now you could have used 1 and 2. You could use 100 and 200. I used 200 and 400 because I already had 200 ready. I'd rather just double that. Onward. Okay, so let's look at these graphs here. So our graph to estimate T of 300, could you put this number into the equation and find out the exact number? Absolutely, you could, but it says to estimate. So we're good with you going to where that X value is 300 on here and seeing that your Y value would be roughly 1.5. So it said estimate, so you can say, okay, about 1.5. What are we measuring on the Y? We're saying that if this is your tailwind, right, as the X, then what is your hours for the flight, right? So we're saying it's going to be a 1.5 hour flight to go that distance, 900 kilometers, to fly 900 kilometers. It'll take an hour and a half. Okay, what is T3? What does that mean? Well, kind of just answer that. That means with a 300 kilometer per hour tailwind, the flight will take 1.5 hours. Now, tailwind, that's behind the plane, right? So as the tailwind goes up, it makes sense that the plane would go faster, okay? Where is the vertical asymptote? Well, remember, vertical asymptotes are when your denominator equals 0. So 300 plus W equals 0. How do we make that 0? Take 300 away from both sides. And when our wind is negative 300, remember, tailwind, so this would be a headwind of negative 300, right? So when we have that, what does the asymptote mean in this situation? It means that this wind, it's no longer a tailwind. It's no longer pushing us forward. It's pushing into us. It's making us stay still. So it tells us that if the tailwind is negative 300, the plane will never travel 900 kilometers. So the tailwind would push us forward, right? And then if that tailwind actually became negative, it would push us backwards. So as long as that tailwind's strong enough, it would push us backwards. We'd eventually go 900 kilometers. But if they are the exact same, the wind and the speed of the plane, they stay still. Okay. So basically, the plane is still. So if this kept going backwards, we would have a vertical line here, an asymptote that we would never hit because that's when that flight, the slower we go, the longer the flight's going to be. But if you're standing still, not going forward or backwards, you're never going to travel that distance. Okay. Consider the equation x squared plus x plus 2 equals 0. I like splitting the square. I like factoring. But the fact of the matter is, this particular equation, this quadratic equation, I can't do either of those things with it. Okay. So I am going to have to use my quadratic equation. All right. So it says use an algebraic method. I need to use the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. Okay, so if I'm going to do that, it's my A, it's my B, it's my C. I'm even going to write D for discriminant because I like to find the discriminant first. So, forgive me for using some of this. Well, I'm going to use the room down there eventually, but our discriminant is just B squared minus 4AC. So A, B, and C, we've got 1, 2, discriminant. That's what we're about to figure out. B squared, we got 1 squared minus 4 is 2. So 1 minus 4 times 1 times 2, we've got minus 8. 1 minus 8 gives me negative 7. Don't stop here just because you have a negative. This negative discriminant, this tells me I have 2 imaginary solutions. So the square root of negative 7, in other words, my discriminant is going to be square root of negative 7, which we would say is I root 7. If you wrote root 7I, I think you'd be all right. Okay. No one's gonna mark you off for that. Okay. But we've got root of negative 7, which is positive and negative I root 7. So now we have to do the other part of our equation. Since we've done this discriminant, the opposite of B just makes it opposite of B plus and minus I root 7 all over 2a. Okay, so what is the opposite of B? The opposite of B is negative 1. So you have x equals negative 1 plus and minus I root 7. 2a in this case would just be 2 times 1, right? So over 2. I think it's I root 7, but if you wrote it as root 7i, I think you'd be okay. All right. Now, I know a lot of my work threw some things off. So which could be the graph of this equation? Look, 2 imaginary solutions. That means our solutions are not actually going to hit the x-intercept. Here we have 2 real solutions, right? That's real. That's real. There's only 1 here, but it's still real. This up here, it's floating. We're not actually touching the x-axis. So it's an imaginary solutions. So this graph has to be the one that matches. How the graph chose relates to your answer because imaginary solutions go with floating parabolas. Ran out of room. Sorry. Floating parabolas, aka parabolas that don't actually cross the x-axis. You have to imagine it. Okay. Good luck on your exams. Cunningham out. Now let's see if I can stop the recording. Pause/stop recording. Good luck.